God, I hope that worked. Okay, so let's take a peek at this. All right, so you guys should be on page 132 if you're not there yet. So today we're going to find the sum of measures of exterior angles and interior angles of polygons. So this is something I want you to add in that blue area because these are the names of the polygons that you are responsible for. I know it's a lot of writing, but trust me, it'll be worth it in the end. If you don't remember these names, I recommend note cards because we're not going to have it available for you on the test, okay? So the names of polygons you are responsible for are triangle, quadrilateral, a pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon, and after 12, it's just an n-gon. You would put like 13-gon, 14-gon, 15-gon, okay? So if we look here, this is an example of a convex polygon, and this is an example of a concave polygon. Okay, so a concave polygon, it's like something that's caving in on itself. We kind of talked about that in topic 1. But convex, it has an outward shape, kind of a little bit more circular, okay? So I'll give you a minute to write this down. Okay, so let's move on to, we're going to skip this. This is just a bit much. We're going to go straight into this. I want you to either write this in your book or on the back of your foldable. This is part of your missing information, okay? So the polygon interior angle sum theorem. The sum of the measures of the interior angles of a convex n-gon, so that could be any amount of sides, is 180 times n minus 2. So if you had, let's say, a 15-gon here, 15 would go in for n. So just a brief example, right now we have a side, a 7-sided figure. What is that called? What's the 7-sided figure called? Yep. Heptagon. It's called a heptagon. Okay, so if we added all those angles up, they would equal 180 times n minus 2. So this is only for the interior, not the exterior. And these numbers are going to get quite large, and that's okay for the inside, okay? So in this case, it's 180 times 7 minus 2, which leaves us with a total of 900 degrees. Now, I'm not as worried about you writing down the example as I am the rule. You guys should know the rule, okay? And then we're going to get into its corollary. Something I've mentioned that one before, right? That word. Now you get to see kind of what it is. Show of hands, who is still writing this? Okay, I'll give you another minute. Okay, so this is the corollary that you should also write either in the blue area or on the back of your foldable. So this is the corollary to the interior angle sum theorem. And basically what this is saying is the measure of an interior angle of a regular, this is the key word here, regular n-gon, okay? What they mean by regular, who remembers what the term regular means? It's mentioned a couple of times this semester already. Who remembers? Nobody remembers what regular means? Deals with congruency. What do we know is congruent with the shape? Sides or angles, or both? Ooh. It's angles and sides. They're all congruent. Okay? All angles are congruent. All sides are congruent. Please, please, please remember that. Okay? Please. So if we took a look at this, this is a five-sided figure. What is a five-sided figure called? Yep. Pentagon. All right. So if that is the case, we are going to take 180 times 5 minus 2. That gives us the entire sum of the angles inside. But then we're going to divide it by the number of sides we have, giving us a total that each of these is equal to 108. Okay? Questions on that? Anybody still writing? Okay. Okay, so let's move on. Let me clear that out. All right, so we're on page 132 in our workbook. So it says, how many triangles are formed by drawing diagonals from a vertex in a convex octagon? So when we're drawing this, your best bet is to draw 8 points, however you wish. It does not have to be a regular shape or perfect, but 3, 4, 5, 6, 7, 8. Okay, and then just connect them. So when we're talking about creating these triangles, okay, so I'm going to pick a vertex and I am just going to connect all the vertices opposite it. So let's say if I chose this one, I would connect from there to there. So how many triangles did I get here? Who can tell me? Yep. I got a total of 6. So that looks very similar to this n minus 2 idea. If we have an octagon, which has 8 sides, we're subtracting 2 from them to get the total of 6 triangles. Now someone tell me, if I was going to add up all these degree measures that this triangle is giving us, these triangles are giving us, how many degrees are in a triangle for me to utilize this? How many degrees are in a triangle? 180. So this is 180 times the 8 minus 2. So that is where this whole interior angle theorem comes from. It's broken up by these triangles. All right, so this is part A. We know there's 6 total triangles. Okay. And then they're asking, what is the interior angle sum for the convex octagon? Well, we're just taking this and we're calculating it for part B. Who can tell me what's that going to be? How many degrees? It's going to be large. No, not large, but large-ish. Yeah.
1,900 or 1,080.
1,080. How many of you were like, oh, that is way too big? No, they're going to get bigger from here, guys. It's not going to. That's not going to change. Very large numbers are coming your way. Okay? Questions on that? Okay. Anybody still writing? We are not doing that. All right, let's take a look at example 2. So for part A, I want you guys to calculate that one on your own, and then we'll talk about part B. Okay, go ahead. Calculate part A on your own. What we get for part A? Who can tell me? Go ahead, Ian. 2,700 degrees. So the more vertices we add, the bigger the numbers get. Okay? All right, for part B, we're going to have to do a little bit different of a setup because now they're saying each angle of a regular n-gon measures 172.8 degrees. So what they're saying here is if you just took a measure of that one interior angle, it would be 172.8. All right? So they're asking you how many sides does the n-gon have? Well, we're going to use the corollary for that. Okay? So that means we're going to set this up in such a way we're going to have 180 times n minus 2 divided by n. But we're setting that equal to 172.8. So how many of you love fractions in here? Ooh, just me. Tough crowd, tough crowd. That's okay. Someone tell me, what would I do to get rid of the fraction? Yeah. Multiply both sides by n. Nice job. Okay. So we're going to multiply both sides by n, and I'm going to distribute the 180. That makes it a lot easier to solve. If you want, you could also divide everything by the 180, but you're going to get some very funky decimals. I don't think you want that. Okay? Question so far where this is coming from? How we doing? Everybody copying this down okay? All right, so now we're going to solve. So we subtract the 180n from each side. So you're going to get two negative numbers, and that's okay. There's nothing wrong with that. Okay? And then, and then you divide by the negative 7.2n on each side. That should leave you with 50. So if we wanted to name this, which we should, because we should get into that habit, this would be a 50-gon. That is how we would name it. Okay? Questions on that? Anything? Everybody still writing? Okay, I'll give you a minute. You good? Okay. Okay. So now this is the other part I want you to write on the back. Again, not the example necessarily, but definitely the rule. So it says Polygon exterior angle sum theorem. So this is the biggie. The sum of the measures of the exterior, so the outside parts, of a convex polygon are, and that means one angle at each vertex. That is a big, big deal. Okay? Don't put multiple angles at the same vertex. That throws everything off. But in the end, they're all equal to 360. So if we look, what happens is if you have a pentagon, you should have 5 exterior angles. If you have a nonagon, you should have 9 exterior angles. Make sure you're not getting like 12 or 15, because it's very easy to kind of add another one here or add another one here. Do you guys see that? And then you have 3 angles coming off of that. That's problematic. We don't want that. Okay? Just make sure you have 1 at each and you should be good. Okay, so in this case, what they're saying here is if I added 1 plus 2 plus 3 plus 4 plus 5, it is going to equal 360. That will not change, ever. It is consistent as gravity. Okay? Now, do you guys remember when we talked about the rotational symmetry? You guys remember that? Where I said... Do you guys remember the rotational symmetry stuff? How did we find rotational symmetry in a shape? Who remembers? Because I said you're going to see this again, but just in different context. Anybody? Bueller? Bueller? Anybody? Okay, so it was 360 divided by what for rotational symmetry? Yeah, the n, right? The number of vertices, the number of sides. You're going to see that again here. It's just in a different context, okay? So, let's move on. So looking at number 3, what is the sum of the exterior angle measures of a convex 17gon? Who can tell me? Top of your heads, what is it? Should be pretty easy. Sum of the exterior angles. Oh my goodness. Okay. What did we say it was? Yeah?
Like 21. One.
Not the individual, just the whole thing.
Oh,
360. It is just 360. You're just adding them all up. It does not matter. It's 360 degrees. Okay? Only for exterior, not interior. Interior's got that whole 180 n minus 2, and then the corollary is divided by the n. Okay? Questions on that? Okay, I'm going to go through this one with you guys first. Okay? So we're going to suppose that 1 and 3 are congruent to each other. So I'm going to mark that. We're saying that the measure of angle 1 is 3x. So this means this is also 3x. The measure of angle 2 is going to be 2x. And it says, what is the measure of each exterior angle? So in this case, what's 5 going to be? It's a right angle, so it's what? 90. That means also angle 4 is what? 90. So in order to set this up, we're going to have 1 plus 2 plus 3 plus 4 plus 5. So this will be 3x plus 2x plus 3x plus 90 equals what? 360. Ah, I did not mean to do that. Take a minute and solve for it. That's a 3. What do we get?
X is 22.5.
X is 22.5. Good job. So X is 22.5. What do I do with this 22.5 to find all the angles? 4 and 5 are done, but I need 1, 2, and 3. So what am I going to do?
You gotta put the X in on angles 1, 2, and 3.
Yeah, we're going to substitute that in. All right, so for angle 1, we get 3x. 3 times 22.5 gives us 67.5. We know that 1 and 3 are congruent, so we can just match that. And then for 2x, or for measure of angle 2, it'll be 45 degrees. So this gives us right here all of the angles that we need. Okay? Questions on that one? All right. Try this one on your own. I did set a few things up. I'm just going to show you that. So I just kind of showed you the congruency marks. But try this on your own for a minute. This is definitely a no snap moment, okay? So if we take a look, we know that 1, 3, 4, and 6 are congruent. We also know 2 and 5 are congruent. The key here is that that measure of angle 3 is equal to the measure of angle 2 plus 30. All right? We got to define the measure of angle 2. What do you want to call it? If you want to call it the measure of angle 2, you can. That's kind of rough. I called it x. So if this ends up being x plus 30, that means this is x plus 30. This is x plus 30. This is x plus 30. This is also x plus 30. Now here's the next part. We just said the measure of angle 2 is x. So that means this is x and this is x. So it's this plus this plus this plus this plus this plus this equals 360.
I knew that.
You knew that?
I just didn't want to say anything. So what, 6x plus 120 equals 360?
And I just defined the measure of angle 2 as x. So there's the setup. See, remember what I said? Oh snap. There's your oh snap moment for the day.
I see.
Okay, so solve for this and someone tell me what is x and then what is the measure of angle 4.
X is 40 and the measure of angle 4 is 70.
There you go.
I got that. I knew that all along. I just didn't say anything.
You don't like
You didn't say both of them. We're just
Okay. That's okay. Yeah. All right, any questions? Anything I can address? Okay, so I don't want you to have like a ton of homework tonight, so your homework assignment is on Savas. Just gonna get going on that. But in addition to that, work on, if you can do that, that Google form for me, I'd appreciate it. Again, you won't, as long as you're not like, be as honest as you can be just about what happened today, okay? Just let me know. Those of you watching at home, have a great day.